So welcome to 6.5, solve systems of linear equations by elimination, right? We spent 2 days now on the substitution method. The substitution method works great when one of the equations has y by itself. But what if they're both in standard form? It's not the greatest method because then you'd have to rearrange the equation to get y by itself. So when they're both in standard form, there's a faster way, and that's what you're going to learn today. We're going to remind ourselves of how to do substitution. So don't worry about graphing it. I'm going to graph it. I put the y by itself equation on the bottom just so you would see that. All right, and we're going to put that in there. And so we substitute in the 3x plus 7 because if it equals the first y, it equals that y as well, or the y next to it. And then we're going to do distributive property, 3x plus 6x plus 14 equals 5. 9x plus 14 equals 5. We're going to subtract 14 from both sides. And 9x equals negative 9. Yeah, divide both sides by 9. And x equals negative 1. Okay, I'm going to put that's the x coordinate. Then we're going to put that in the bottom equation. 3 times negative 1 is negative 3 plus 7. Negative 3 plus 7 is 4, and so these should intersect right here at negative 1, positive 4. Let's see if the graph agrees with that. Now the top one, right, looks like that. It has some fractional intercepts. If you found this intercept, by the way, I think it's 0, 2.5, and this one over here, I don't think I graphed it all that great, but is 1 and, I believe it's 1 2/3. Yeah, 1 2/3, 0. So graphing really wouldn't have been good here. Right, a lot of fractions. And then there's the bottom one with the y-intercept of 0, 7 and the slope of 3. That one graphs very nicely. And there's the intersection, negative 1, positive 4. All right, so that was the substitution method, right? You substituted 3x plus 7 for the other y. Okay, now here it is, two equations, both in standard form. Now you could manipulate this equation or either equation and get y by itself and then do the substitution method. But there's a better way, and that's today. Okay, so let's remember. Equations remain true as long as you add or subtract equal amounts to both sides. But the amounts do not have to be in the same form. What? Well, let's see this. It says add 9 to both sides and see if the equation remains true, right? So that's a true equation. You add 9 here, you add 9 here, you get 14 equals 14. Tell me if that's true or false. I got to write it correctly. It's true. So now, let's do this again. We're going to add 9 to one side, but on the other side, we're going to add 3 plus 6. All right? So on this side, you get 9 plus 5 equals 14. 5 plus 3 plus 6. Well, 3 plus 6 is equal to 9, so you still get true equations, right? But this is the key thing of why today's method works. If you add 9 to both sides, it could be 9 on one side, and it could be 3 plus 6 on another side. It could be 1 plus 8 on another side, right? Anything that adds up to 9. So let's see how that trick or that thought process works today. It leads us to the elimination method. An elimination method states that you can solve in a system of linear equations by adding or subtracting them together. The two equations can be added together to eliminate x or y. This works because the two sides of any equation are always equal amounts, right? If you write 7 equals 7, right, that's what an equal sign means. So both sides are the same amount. So when you write 3x minus 4y equals negative 14, that means that side is equal to negative 14. That's the same as writing negative 14 equals negative 14. Yes. All right, so if that is true, what that means is that you can add equations together. And that's what we're going to do. So we're going to write a big plus sign here, and we're going to write a big line underneath them, and we're going to add them together. Let's see what happens here. Well, 3x plus 5x, 8x. Now we have negative 4y, because that minus has to go with the 4y. Negative 4y plus, we're adding, positive 4y. Well, what's that? For any value of y, that's 0. What happened to the y? It's been eliminated. This is the elimination method, okay? And negative 14 plus 30, well, 30 minus 14, I'm going to flip it over, is 16, all right? Let's solve that equation. Divide both sides by 8, x equals 2. So these two lines must intersect where x equals 2. Now, that was really easy. The harder part of elimination is the next step, because we don't have an equation in slope-intercept form where y equals blank. We don't have that. But so we can pick either one. I'm going to pick the bottom one. We're going to substitute the 2 back for x right there. That's where we did it. Right? And we're going to solve that. So solve that. Right? You get 10 plus 4y equals 30. So I'm going to subtract 10 from both sides. 4y equals 20. Divide by 4. Y equals 5. And it turns out these two lines intersect at the point 2, 5. Right? This is called the elimination method. You can add or subtract equations together. And this is always true because this symbol says that they're the same, right? And the two sides are the same. And the rules of equations say as long as you add, subtract, multiply, or divide the same amount to both sides, everything remains true. So let's see that again. So let's add these together. Now this one, the x's will be eliminated. In the last one, the y's will be eliminated. Both work. Negative 2x plus 2x is 0. 7y plus negative 4y is positive 3y, right? That minus goes with that. That plus goes with that. Negative 20 plus 14. Please always write this nice and big. You'll see why in a second. Equals negative 6. Divide both sides by 3. Y is negative 2. So now we have the y coordinate, right? We're not done. We got to also find the x coordinate. So we can put that negative 2 in either one. I'll put it in the top one this time. Either one gets the same answer because it's where the two lines cross. So we have negative 2x plus negative 14, which is minus 14. Let's just write that out. So we add 14 to both sides. Negative 2x equals negative 6. Divide by negative 2. And x equals positive 3. These lines cross at the point 3, negative 2. All right, now let's look at this one. If we add them together, don't copy that, you're going to get 6x there, and you're going to get 9y there, and you're going to get 30. Now, it's still true, except nothing's been eliminated, and so it doesn't help us figure out what x and y are. So instead of adding these, let's try something else. Let's try subtracting the two equations, and this is why I said you want to write nice and big right there that you're subtracting the two equations. So you're going to have to look at them in the homework and decide if you're adding or subtracting. So let's try subtracting them. 3x minus 3x, 0x. 7y minus 2y, positive 5y, right? That's positive 5y. Now it's 25 minus 5. Be careful. People mess up the subtraction ones because they don't remember that they're subtracting the top minus the bottom. Well, now we just divide both sides by 5. We found out that the y coordinate is 4. So now we got to go find the x coordinate. Either one works. I'm going to put it in the bottom. That's plus 8, so I'm going to subtract 8 from both sides. 3x, 5 minus 8 is negative 3. Divide by 3. X equals negative 1. And that is the point where the two lines cross. So, right, so if you see opposites, anywhere, like negative 2x and 2x, you're adding. If you see the same, you're subtracting. And it could be either x or y. So we're going to practice this a bunch. Here we go. All right. Now, this method is the best method when they're both in standard form, okay? But what if they're not in standard form, both in standard form? Yeah, you got to line everything up, right? Notice, you know, everything's got to line up. The x's have to line up, and the equal signs have to line up, and the y's have to line up. This is not lined up, okay? So we have to line it up first. So let's see that. So now, all you have to do is make them all line up. But I'm just going to make them always be in standard form. So the bottom one is not in standard form, right? So how would I get it in standard form? Oh, I'd add y to both sides, okay? And so now that's 2x plus y equals 10. The top one, I don't have to do anything to, right? All right, it's already in standard form. And why did I do that? Because I need everything to line up. The x's have to line up, the y's have to line up, the equal signs have to line up. And you can't just scrunch things over. That doesn't work, all right? So now I have to look at it. Now that I've done that, now I look. Am I adding or subtracting? Well, we have the same y's, so we're going to be subtracting. Write that. 6x minus 2x is 4x. Y minus y is our 0. 18 minus 10 is 8. Divide both sides by 4. X equals 2. So now we go get the y coordinate. I'm going to use the top one. 6 times 2 plus y equals 18. 6 times 2 is 12, so subtract 12 from both sides. Y equals 6. And so those two lines cross at 2, 6. Right? So for this method, they all have to line up. The way I'm going to do them, put them both in standard form. All right, so now, right? The top one's in standard form already, but the bottom one, now notice, x and y are on the correct side. It's just that the x's are under y and the y's are under x's. So we're not going to add anything to both sides. What are we going to do? Pause and try it yourself. So we're leaving the top one alone because it's already in standard form. The bottom one, we're just going to use commutative property. What we're going to do is we're going to put that in front and make it negative 3x. Right? That minus moves with it. And this negative 2y goes in the back and becomes minus 2y. Now everything, now that is not technically in standard form according to some people because the first number is negative, but it serves our purpose. All right, so now we look, are we adding or subtracting those two equations? Well, I see opposites, so we're adding them. 3x plus negative 3x is 0. 6y plus negative 2y, positive 4y. 12 plus negative 6, 6. Ooh, are we going to get fractions here? I'm going to double check my work just to make sure I haven't messed up. And we have 12 plus negative 6. Okay, so we're adding 6 plus negative 2y. All right, so we got divide both sides by 4. And y equals 3 halves, right? You could write that as 3 halves or 1 1/2. Okay, and so then x, we're going to put it in the top one. So 3x plus 6 times 3 halves equals 12. I'm going to do a little canceling there. 3x plus 9 equals 12. Subtract 9 from both sides. 3x equals 3. Divide both sides by 3. And x equaled 1. So those intersect at 1 3 halves or 1 1 1/2. Okay. And I'm just going to double check my work since I got that fraction. So let's see, the y is 3 halves. I'm going to put it in the bottom equation. This is how you can check your work and see if I'm right. This makes it true. Oop, it was positive 1 there, right? So let's see, those cancel and you get negative 3. 3 times positive 1 minus 3. Negative 3 minus 3, does that equal negative 6? Yes, that is the correct answer. It checks out. All right, let's practice. All right, is everything lined up? No, it's not. All right, the bottom one is good to go. So I'm going to leave that one the same. The top one, however, right, x and y are on the same side, so I don't have to add anything to both sides. I just have to rearrange. So minus 8x becomes negative 8x. Y becomes plus y. All right, so am I adding or subtracting? I'm adding. Because negative 8x plus 8x is 0. Y plus negative 4y is negative 3y. 3 plus negative 12 is negative 9. Divide both sides by negative 3. Y equals 3. We have the y coordinate. Now we can put that in either place. Ooh, this will be interesting. I'm going to put it in the top. 3 minus 8x equals 3. Subtract 3 from both sides. Negative 8x equals 0. Divide both sides by negative 8. What's 0 over negative 8? 0. These cross at the y-intercept. 0, 3. Interesting. If I'm unsure of that, I double check my work. All right, I can put it in the top. 8 times 0, the x-coordinate is 0. Minus 4 times 3 is negative 12. That equals negative 12. It makes both equations true. It's the one point where they intersect. Right? That solution is where the lines cross. The only ordered pair that makes both equations true. Same thing. Oh, okay. Now we got to get x and y on the same side, right? So the top one is good to go. I didn't give myself enough room, though. So I'm going to have to rewrite things. This one, I'm going to add 3y to both sides. And so I'm going to get this new equation, which is x plus 3y equals 23. Am I adding or subtracting? I'm adding this time. 4x plus x is 5x. I have opposites right there in the y. Negative 3y plus 3y is our 0. Negative 13 plus 23 is 23 minus 10, right? Divide both sides by 5. X equals 2. We have our x coordinate. Now we need our y coordinate. I'll put it in the top. Put it in the top one. I'll do it up here. I'm putting it up there. So 4 times 2 minus 3y equals negative 13. We're subtracting 8 from both sides. Negative 3y, negative 13 minus 8, negative 21. Divide by negative 3. Y equals 7. 2, 7 is where those two lines intersect. Okay. Well, what are we going to do here? Like everything's the same. Well, I said when it's the same, subtract. So let's see what happens. So we get 0 plus 0 equals 0. So we get an equation that says 0 equals 0. Is that true? Yes. What happens when it's 0, 0? This is infinite solutions, but what does that mean, infinite solutions? It means the same line twice, right? I didn't even disguise it, right? It's clearly the same line twice, right? There's the top line, there's the bottom line. They hit infinitely. Final question. Replace the question mark with a number to make a system with no solution. All right, we need no solution. So let's see this. Well, we have y's that are the same, so I'm going to subtract here, right? And this will be 0 no matter what I do. And 5 minus negative 4 equals 9. And so if we put any number other than 2 there, right? If we put any number than 2, we're going to get an x. We're going to get an answer. We're going to get two lines that cross. So the question mark has to be 2, right? Because then you get 0 plus 0 equals 9. 0 equals 9 makes no sense. That's no solution. And so once there's a 2 there, what does it mean about the two lines? It means they have to be parallel. That's what it means. Let's see if we graph these. There they are. That's the two lines. The top one, the top one is the blue one, because if you subtract 2x from both sides, the y-intercept of that one is 0, 5. All right, that's very sloppy, but yes. And let's clean that up. And that's 0, 5. And the bottom one is the one with the y-intercept of 0, negative 4. But they have no solution, right? They are parallel. They do not intersect. Good luck with the homework.